Alright, so as you guys saw, we are going to be dealing with some shapes in this chapter. Really, this is kind of an intro into some of the basics of what you will do with shapes in your math career. Before we can get too carried away, we have to kind of identify some things. So you'll see some three-dimensional figure drawing. Don't focus on the fact that maybe your drawings don't look the greatest, because really drawing these shapes, it's just trying to give you an idea of all of the parts of the shape, not necessarily how to draw them efficiently. But when we draw these shapes, it helps us understand how many sides there are, how many edges there are, how many vertices there are. Things like that are things that we get when we draw these shapes. So looking at this first part, again, we need to be able to identify some things, and these are just some of the basics, and you can see along the left-hand side here we have some key vocabulary, and most of it is all just defined right here in this first key concept box. First of all, we have a solid. It's a three-dimensional figure that encloses some kind of space. A solid would be anything from a pyramid to a prism to a cone to a cylinder, anything that you can physically see that you can put something into. If it were a real figure, would be a solid. A polyhedron is a solid whose faces are all polygons. So again, polygons just means many sides. Polyhedrons are going to be anything from pyramids to prisms. Basically anything that does not have a circular edge would be a polyhedron. Face is a flat surface of a polyhedron, and again, notice it says a flat surface. There's not any one thing that you can call a face. All of those edges and sides are faces. So for instance, if I'm looking at this front side right here, that would be a face. The top side that the arrow is pointing to is a face. Every single one of those things is a face of some kind. So you know, those are all examples of faces, and again, there's no just one answer. A lot of those things are faces. Same thing with edge. Edge is just a line segment that encloses one of the sides, and a vertex is any point. So what we'll do for some of our examples is actually just count up all of the edges or all of the faces or all of the vertices, and again, that's just where any two sides meet, or excuse me, anywhere any faces meet as an edge. So it says a point is where three or more edges intersect. An edge is a line segment where two faces intersect. A face is a flat surface of the polyhedron. So example 1 here, again, it just says find the number of faces, edges, and vertices of the solid. So what you will do is find the number of faces and write that out. So if I look here, this top side right here is a face, and then opposite it would be this bottom, that big bottom square. All of that is a face. So there's 2. Then I have this trapezoid face on this side, and its opposite on the bottom side here. So that would give me 4, and now I have a rectangular face here and its opposite over here. So you can see it says that the solid has 1 face on bottom, 1 face on top, and 4 faces on the sides. So a total of 6 faces there. Line segments, again, are anywhere where 2 faces meet. So we have, here's a line segment, here's a line segment, there's 2, this dotted line 3, this line 4, so I've taken care of all of the horizontal lines. Then I have these ones that are kind of offset. There's 5, there's 6, there's 7, there's 8, and then we have the vertical ones 9, 10, 11, and 12. What some students will do when they count to kind of make sure they keep track correctly is they'll put a hash mark through them. So let me get a color here that'll work okay, and you guys will be able to see. So when I'm counting my faces, I can get my shape, and again, especially because our book is online, this will help us out. So again, counting those edges or those line segments, we have 1, 2, 3, 4. So now I'm not going to accidentally count those again. And then let's say 5, 6, 7, 8. And then I have 9, 10, 11, 12. Again, the same thing can be done with the vertices. If I just get a different color here, I'm just going to circle them 1, 2, 3, 4, 5, 6, 7, 8, and those are all of the vertices. So for your practice on example 1 here, I know I kind of drug that out, just count the faces, edges, vertices. And so down here in your answer, I want F equals, I want E equals, and I want V equals. Count all those things for me. Okay, so as you can see with my marks on the shape, I kind of marked it all up, but hopefully you can count those as well. You should get 5 for faces, 9 for edges, and 6 for vertices. Make sure you got those correct, and then move on to the next section. Key ideas here with a prism. It says a prism is a polyhedron that has 2 parallel and identical bases. Again, prisms, you're going to have anything that you can call a face, but as far as the bases go, they have to be parallel and identical. Those 2 triangles are the only ones that are parallel and identical, and all of those other faces you might have a couple other identical faces, but none of them will be parallel. So you have 2 bases, and then you have the other sides that are the lateral faces. Pyramids, on the other hand, it says it's a polyhedron with 1 base with lateral faces that are always triangles. And when you see things that say rectangular pyramid or octagonal pyramid, pentagonal pyramid, whatever it happens to be, they're talking about the base. So if you hear a pyramid with a square pyramid, you have a square base, and they all meet at a point up at the top called the vertex. So those are the different shapes that you'll see here in this first one. Prism and pyramid. Know the difference between the two, and you should be able to recognize the two. Drawing them, again, you guys, I'm not going to focus on this. It just helps us identify parts. So it says draw 2 identical, this is for drawing a prism. And then part B is steps for drawing a pyramid. So it says draw 2 identical rectangular bases, and then it says connect all of the vertices that are corresponding. And corresponding just means that those points should meet up. So you should connect these corresponding vertices here, 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 and here. That gives us our second figure. And as you'll see, what they say is to erase and make the lines that should be hidden dashed. So this line back here would be hidden, this line here would be hidden, this line here would be hidden. So you wouldn't be able to see those if you were looking at it as a 3-dimensional figure. I feel like drawing pyramids is a little bit easier because you just have to draw the base and then a point up above the base and then connect all of those vertices to the point. Once again, pretty much everything in a prism will be dashed because it's all going to be behind one of the lateral faces. So drawing the different views of a shape would be kind of another thing. It says draw the front view. Well, depending on what you want to do, you can kind of technically call a couple different things the front. But when they drew the front view, this is what they drew. When they drew the side view, they used this as the side. And then from the top, they used, let's get a different color here, but you guys can kind of see this. From the top, they used this face right here. So you can see that you have kind of a parallelogram, a small rectangle, and a big rectangle for those different views. So here to finish out the lesson, you guys, we have draw a square prism and draw a pentagonal pyramid, along with draw the front, side, and top views of the solids. So pause the video, make sure you guys can draw those things, and I'll kind of go over them with you a little bit here in just a moment. Okay, so I was planning on actually just drawing these without recording, but again, make sure you try these, but I'm going to draw these for you so I can kind of show you a little bit how to do this. So again, a square prism, we want 2 identical faces that are squares. And then what we want to do is we want to connect corresponding vertices. Now, again, I'm not going to be able to erase once I'm done, so I'm going to draw the sides that I can see first. So I'll be able to see this side, and this side. and then this back side is going to be dashed. So I'm going to draw that dashed. And actually, this vertical side back here is going to be dashed, and this side right here is going to be dashed. Again, you guys can erase, but that would be kind of roughly what your prism would look like. Again, mine's kind of shaky here because I'm on an iPad, and you guys can do this on paper. But pentagonal pyramid, again, those are a little bit easier. All I need to do is draw the basic shape. A pentagon has 5 sides, so I need to make sure I have a pentagon. And then I'm going to draw my vertice up above. So let's say this is my vertice. Then I connect my faces that are hidden. So this would be hidden. And let's just say this you would see, this you would see, this you would see, and this you would see. So again, the other hidden side would be these two back here. But you can see that those faces are triangles. But that's roughly, like I said, I'm not going to grade you on your artwork. Basically, what I'm going to check for is that you understand what it should look like. Then what we have here are the front, side, and top views of the solid for number 4. So from the front, I would say here's the triangle that you would see from the front. From the side, I would say that you're looking at a rectangle. And from the top, actually that one's kind of an interesting one. From the top, you would see a rectangle with a line down the middle because that triangle's point is cutting that in half. So that would be the top view of that. Number 5, the front view of that thing would just be a skinny triangle. Okay, the side view would be exactly the same triangle. And then the top view would actually be a square. And there would be a point in the middle of the square and lines connecting everything to the middle point. That's basically what every pyramid would look like from the top, and the only thing that would change would be the side numbers. So if I drew this pentagonal pyramid right here from the top, it would be a pentagon. If I can kind of improv draw it here, let me retry that. If I can get this drawn correctly. So we have a pentagon, and then it would be a point in the middle, and every vertex would be connecting to that pentagon. So again, that would be the top view, T-O-P. Okay, so again, you guys, a lot of just basics in this lesson. You'll have plenty of time to get this lesson done. If it takes you a little bit, that's fine, but make sure you guys are reading the directions and answering questions completely. Don't leave any of this stuff out. And like I said, you may want to use graph paper if you're someone who doesn't mind doing it on the iPad. In Math Tool Paper, there are graph paper things there as well. So make sure you guys take advantage of that stuff.